This is the screencast for section 2.2, example 2. We're going to revisit the sandwich theorem. In other words, we're going to use it. So finding a limit as x approaches infinity. Well, find the limit as x approaches infinity of f of x for f of x equals sine of x over x. No, why didn't they just put sine of x over x in there? I don't know. Whatever, we still have to find the limit as x approaches infinity. So you have a limit memorized for sine of x over x, but that's the limit as x approaches 0, and it's 1. We're looking for the limit as x approaches infinity. Well, the sign of infinity is weird because sine fluctuates between -1 and 1. So I don't really know what's going to happen. And now x is going to get infinitely large, so I can predict what's going to happen. If the numerator only goes between -1 and 1, chances are my limit is going to get smaller and smaller and smaller and approach 0. But we need to show that. We need to support why that is the way it is. So we are going to use the sandwich theorem. First, I'm going to separate the limit as the limit of x approaches infinity of 1 over x times sine of x. Now that shows that this function is going to fluctuate between 1 over x and -1 over x. And I know the limit of y equals 1 over x and the limit as y equals -1 over x as x approaches infinity. They are both 0. Remember, -1 over x is just vertically flipped over the x-axis, so it's still going to approach 0 just from the bottom, not like 1 over x that's going to approach from the top. So since those limits are the same and y equals 1 over x sine of x fluctuates in between those two functions, by the sandwich theorem, the limit as x approaches infinity of sine of x over x equals 0. And you can see that on the graph here, I've got sine of x over x as we approach infinity, and then I gave it a little much bigger window here. And we do approach 0. It's just going to fluctuate over and under the x-axis, still approaching 0. Now number 9, we're going to do completely without any picture whatsoever, any graph. The directions say find the limit and confirm your answer using the sandwich theorem. Right now, I don't have a situation of a multiplier by a trig function, a function being multiplied by a trig function. So I kind of got to separate some pieces here. I'm going to do the limit as x approaches infinity of 1 over x squared, and then I'm going to separate that to also minus the limit as x approaches infinity of cosine of x over x squared. Now I know that the limit as x approaches infinity of 1 over x squared is going to be 0. That's no problem. It's this guy. This guy's the problem. So I'm going to change this, just this piece, into a form where the sandwich theorem will apply. And now I know that 1 over x squared cosine of x is going to oscillate between y equals 1 over x squared and y equals -1 over x squared. And I know that the limit as x approaches infinity of 1 over x squared is going to equal the limit as x approaches infinity of -1 over x squared, and they are both 0. As those denominators get bigger and bigger and bigger, 1 divided by a bigger and bigger number is going to approach 0. So now, by the sandwich theorem, the limit as x approaches infinity of 1 over x squared cosine x equals 0. But that's not all that we were trying to find. We were still trying to find the limit of these two functions together. So this being a side note, I now have a new step from the beginning here where I can do 0 minus 0, and my total limit is 0. And I confirmed that using the sandwich theorem. The sandwich theorem was right there. It was part of my confirmation.